All right, guys, I'm going to go over some of the test questions with you, so follow along in your test so you can figure out what mistakes you made. All right, so it's telling me that this is a scaled copy. These are scaled copies, and I want to see which one of these are true. So first of all, I'm going to look at the scaled copy, and if I look at them, that means that my scaled copy from going from this one to this one would be 2. But if I'm going from this one to this one, it would be the opposite, so I'm going by half. Okay, so it depends on which direction I'm going. All right, so let's look at this. Segment EF is twice as long as AB. So it says that this one is going to be twice as long as this one. This one would be twice as long. Yes, because I'd be doubling it. That's true. All right, next one says that segment CD, this one, CD, is twice as long as FG. Well, first of all, that's not even the same segment. So nope, that won't work. All right, the measurement of, let me go another one. The measurement of angle HEF, I'm going to trace that, HEF, so this angle, HEF, is twice the measurement of this one. Okay, well, remember, angles, we don't change the measurement of angles, so that's not going to work at all. All right, the length of EH, I'm going to erase all this so I can see it now. The length of EH is 16. So EH is here is 16. That would be double that. So yes, that works. And the angle EHFG is twice as long. Okay, remember we said that the area. So the area is twice as long. So remember when we talk about area equals, it's the area of the original. Oops, let me write that. It's the area of the original times the scale factor. Okay, times the scale factor squared. Okay, so the area will definitely be different. The area will definitely be different. So it's only this one and this one. Okay. All right, let's check this one. So I want to do a scale factor of 1/2. So the first thing I need to do is figure out what all the lengths are. So I'm going to do that. All right, so I did all my measurements. So now I just need to do 1/2 of those. So I need to go down 3. Then I need to go over 2. Then I need to go up 1, over 2, up 2, and over 4. All right, that works. All right, next one. All right, again, let's see if all of the measurements, let's see, rectangle A has a measurement of 9 by 3, B is a scale copy, so it wants to know which one of these will work. So if I have a 9 by 3, which one of these will work? So if I look at this one, that would be dividing by 2, that works. All right, if I'm going to an 8, that'd mean I'm dividing by 1, that won't work. This one I know for sure would work by 10. Okay, I'm going to do that one. This one, let's see, I would have to be multiplying by a little over 1, and that one doesn't work for that one. This one, if I multiply 9 times 1.5, that gives me 13.5. If I multiply this by 1.5, that gives me 4.5. All right, so it's those 3. Okay. All right, let's go to the next one. All right, the scale drawing has a park. It's 5 inches by 7 inches. The actual area is 280. So what is the area of the actual park? All right, let's look at that. So I'm going to draw a picture because pictures always help me. All right, so right now it says that it's 5 by 7. Okay, it's 5 by 7, but it says the actual park is 280 yards long. So the actual one is going to be, this is going to be 280. So I need to figure out the scale factor first. So how did I go from 7 to 280? I multiplied by 40. Okay, so then I'm just going to follow my formula. So the area is the area of the original. So 5 times 7 would be 35 times the square factor squared. So the scale factor squared to the second power. All right, so then I just need to solve it. So 40 to the second power, that's 40 times 40, so that's 1600 times the 35. That would come up to be 5,000, 56,000, 56,000. Okay. All right, next one. All right, here's the figure A. Which ones of them are all scaled copies? Okay, we actually did one of these. If you look at it, so I want to know which one is a scale factor of this one, a scale factor. So first of all, I can already tell that this one won't work because it's slanted. You can definitely see that one. That one's not going to work. So let's kind of look at my dimensions here. So this is a 2 by 2, and then this is 1 here. Okay, so I want to look at that one. So 2 by 2, it looks like 2 by 2. So if I were to look at this one, this would be a 4 by 1, 2, 3, 4. This one's looking pretty good. And this was 1 here, and now it's 2. So 2 is good. This one is a good one. Okay, let's look at this one here. So I'm going up 1, 2, 3, going up 3, but it looks like this is about the same, so that's not going to work. Okay, so I changed my length here, but not this one, so that doesn't work. Let's try this one. This is a 1 by 1, and that looks like to be about half of it, so that one looks good too. That one looks good, so I would say figures 2 and 4 work. Okay, let's go to the next one. All right, if figure B is a scaled copy of A, so if they're scaled copies, they're both scaled copies, okay? Figure B is larger than A. Well, if it's a scaled copy, it could be smaller too, so that one doesn't necessarily work. It could be bigger or smaller. Okay. Figure B has the same number of edges. Well, that just means if I have a triangle, okay, and a scaled copy of a triangle, it would still only have 3 edges. If it was a square, it would still have 4, so that's true. It would have the same perimeter. Well, that's not true. That's the distance around. Obviously, this one would be getting larger. Okay, so that's not true. It has the same number of angles. Well, yes, if it's a triangle, it's still going to have 3 angles. If it's a quadrilateral, it still have 4. So that's true. And the angles have the same measurement. Yes, we continue to talk about that the angle measurements will not change, All right, that works. Go to the next one. All right, so these are scaled copies. They're all scaled copies. So we need to look to see what the scale factor would be. Would it be 1, equal to 1, or less than 1? All right, so if we're going from R to cube, we're going to go from R to cube. It got smaller, so that means it has to be a fraction. It has to be a fraction, okay? Less than 1, sorry, less than 1, okay? Less than 1. Now we're going to go from S to P, from S to P. Well, that looks like the exact same. That looks like the exact same. So that's going to be equal to 1. Okay. And then we're going to go from S to R, from S to R. Well, that got bigger. So that means it has to be greater than 1. It got bigger. Okay. All right. Let's keep going. All right, there are 2 polygons. I wanted to know if it's a scaled copy. All right, the only thing that you all didn't see, most of you saw, yep, let's see, it went up. Let's see, that goes up 3, whereas this one goes up 1, 2, 3, 4, 5. Oops, that went up 1, 2, 3. So a lot of you were seeing that it looked like it was a scaled copy here. However, do you see here that this measurement did not change at all? If there's any measurement on there that does not change at all, then it is not a scaled copy. It's not scaled. Okay, this looked good here because this was 2 and this was 4, so it kind of was looking, but anytime there is one thing that stays the exact same, it is no longer a scaled copy. All right, last one. A measurement, a rectangle is a 2 by 3 rectangle, a 2 by 3, I like to draw them, a 2 by 3, and it's been scaled by a scale factor of 7. So that just means the next one, I'm multiplying everything by 7. So times 7, that'd be 14, and this would be 21. So my new numbers would be 14 and 21. And then it says, suppose you want to scale it back to the original. So I'm going to go from here back to the original. Well, remember when I went from here to here, the scale factor was 7. So if I go the opposite direction, it's going to be that fraction. It would be 1/7. So the scale factor, if I go from the big back to the small, would be a scale factor of 1/7. Okay? All right, I want you to look through your problems and see which ones you missed. I'm probably going to have you do a flip grid and you talk about the problems that you missed in detail. What were you thinking? Okay? All right. If you have questions, come and talk to me. All right. Have a great day, guys.